Good morning, everyone. So this will be our lesson 4, endogenic processes. Now for today's lesson, these are the learning objectives. So you have to describe where the Earth's internal heat comes from, and then describe how magma is formed, magmatism, and describe what happens after the magma is formed. So we have plutonism and volcanism. So going back again, no, we have the layers of the Earth. We have crust, mantle, and the core. So the core is, as we all know, the hottest layer of the Earth. So the heat coming from this layer is responsible for all geological activities happening on our planet. And then aside from that, due to the different geological processes that is happening in our planet, so volcanoes, mountains, and continents were formed because of this internal heat. So last time we have discussed about exogenic processes, meaning when we say exogenic processes again, these are the activities or processes that is happening on the surface of the earth, while endogenic processes, so it means that geological processes that occur beneath the earth's surface. So lahat ng mga processes na nangyayari inside, di ba, or beneath the earth's surface. Yan. So that is endogenic processes. So we have magmatism and plutonism, plate tectonics, seafloor spreading, isostasy, and plate boundaries. So as we go along the lesson, i-discuss natin yan. Ano-ano bang ibig sabihin nitong mga bagay na to? Yan, ng mga endogenic processes na ito. Now, let's have first magmatism. So, magmatism, it is the motion or activity of magma. No? So, it is the process responsible for the mountain formation, volcanoes, islands, seafloor spreading, and mid-ocean ridges. So, again, magmatism, the motion or activity of magma. So, rocks that are subjected to high temperature and pressure, definitely once mapunta ito sa mantle, syempre napakainit doon, so it will melt and it will become magma. So lahat ng activity nitong magma na to and kung paano ito napupunta sa surface ng earth, that is magmatism. Now discuss lang natin itong illustration na ito, no? So as you can see, yan, kumbaga ito yung activity, no, na nangyayari sa ating magma. So definitely we have here the mantle. So dyan, that is mantle wherein dito natin makikita o dyan manggagaling, diba, natutunaw lahat ng mga bato, no? And then once na mag-melt, so definitely ay na nga magiging magma. And then syempre may mga areas sa lupa, no, o dyan sa ilalim ng lupa na kung saan may mga opening na doon dumadaan etong mga magma na to. So we have here magma rises, yan. So umaangat etong magma, no, due to the different processes na syempre meron din doon sa loob ng ating planeta. And then we have here the magma differentiation in magma reservoir. Ayan, since kasi ito yung mismong kumbaga main magma chamber natin, no, so definitely yan ay konektado, no, diyan sa kumbaga tubo, no, na dinadaanan ng magma kapag ito ay lalabas sa volcano, no. So that is magma chamber or magma reservoir. So there is intrusion, stagnation, crystallization, no. So intrusion, underplating, no. Yan, so ibig sabihin, diyan sila napupunta, diyan sila kumbaga iniimbak, no. And then since nga nagkakaroon ng pressure, sa sobrang taas ng pressure, ang tendency is etong magma natin ay i-eject palabas, no, dahil sa pressure na nangyayari diyan sa lupa, sa ilalim ng lupa, yan, ang tendency dun sa magma, ito ay aangat. So kailangan kumbaga sa tao, 'di ba, sa sobrang stress niya, so kailangan niyang gumawa ng iba pang bagay, no, para mawala, no, ma-enjoy niya yung buhay niya, mawala yung mga iniisip niya, no. So kumbaga dito rin, no, sa mga volcano, so syempre kapag stress na, kailangan ilabas mo yung stress na yan, no, gumawa ka ng bagay na magpapatanggal, no, ng pressure na yan, ng stress na yan. So with that ay nga, no, anong mangyayari? So magkakaroon na tayo ng volcanic eruption, no. And aside from that, syempre aside from magma or lava nga na i-eject nitong mga volcano na to, definitely may iba pang mga materials na i-eject ito. Syempre yung mga gases, di ba? And other materials, no, na meron tayo dito sa volcano or dyan sa mismong magma. Now, talking about magma, so magma, it is a semi-liquid molten rock mixture that can be found in the lower portion of the crust and the upper part of the mantle. So yun nga, semi-liquid molten rock, no. So yun, kumbaga dahil nga sa sobrang init nga kasi, no, diyan sa mantle, so tinunaw yung mga bato, no. Depending on the temperature, pressure, and formation in the crust and the mantle, the magma can be formed in different ways, no. So nakadepende yan sa mga nabanggit, temperature, no, pressure, and then the formation in the crust and the mantle, no. And then we have also, since we are talking about magmatism, dito rin papasok yung tinatawag nating plutonism, no. Plutonism, meaning it is the formation of intrusive igneous rock by solidification of magma beneath the Earth's surface. So, ibig sabihin, yung tawag pala sa process, no, yung general term pala dun sa pag-create ng intrusive igneous rock ay plutonism. Bakit siya tinawag as plutonism? Pag sinabi kasi nating plutonism, meaning lower world. Lower world. Ibig sabihin, nasa ilalim, no? Nasa ilalim ng ating lupa, no? Kumbaga, lower world. So, as is na yan, no? Sa ilalim ng lupa. Yan. Now, plutonism is the geologic theory that the rocks forming the earth were formed in fire by volcanic activity with a continuing gradual process of weathering and erosion, no. And then aside from that, ayun nga, no, dahil dito sa etong plutonism din, no, tinatawag din siya by the way as volcanism, wherein it explains that the rocks are formed by or in fire by volcanic activity. So yun nga, nabubuo etong intrusive igneous rock because of the magma na nabuo, no, inside the earth, no. Next, we have here, ayan, another explanation about plutonism. So plutonism, on 1788, James Hutton developed the idea about plutonism, and he stated that the formation of intrusive igneous rocks or plutonic rock na tinatawag came from the solidification of magma beneath the Earth's surface. So ibig sabihin yun pala, no, si James Hutton pala nag-develop nitong idea about plutonism, na yung magma once na mag-solidify beneath the Earth's surface, that is what we call intrusive or plutonic igneous rock, no. Now these rocks will reach the Earth's surface through the process of uplifting. So alam naman natin yun, di ba, na may different kumbaga deformation na nangyari sa crust natin, and dahil doon nagkakaroon ng tinatawag na uplifting. Ibig sabihin, umaangat ang lupa, no, at dahil doon na-expose tuloy etong mga intrusive igneous rock. So with that, napupunta sila sa surface ng Earth, no. So pag sinabi nating uplifting, it is a force that pulls the crust apart and lets the rocks from the underground to be brought up. Now, what are the causes of the formation of the Earth's crust, no? So we have here plate tectonics. So sabi dito, the Earth has plates that are constantly moving. So this plate tectonic theory, no, theory yan, it explained that the lithosphere daw was so brittle, no, sobrang lutong, that it was divided into major plates considered to be floating over the hot liquid of asthenosphere. O yun nga, dahil dun sa ayan, sa mantle natin, kumbaga nakalutang, nakapatong lang, no, itong ating mga tectonic plates, no. Now, there are a total of 7 major plates. We have North American plate, yan, we have South American plate, yan. Ano pa, we have Pacific plate, and then we have African plate, diba? Yan, so napakarami. And then we have also Eurasian, Australian, and Antarctic, no? And then there are 6 minor plates naman, namely Cocos, no? So ito yon, yung Cocos. And then we have also Caribbean, yan, Caribbean plate. And then we have Nazca plate. So nasan ba yung Nazca plate? Ayan, Nazca plate. Scotia plate. So asan yung Scotia plate? And then we have also Arabian plate, no? And then we have, of course, Philippine plate, no? So those are minor plates, no? So we have 7 major plates, and then we have 6 minor plates, no? Now, plate tectonics is the theory that the Earth's outer shell is divided into several plates that glide over the mantle. And again, pag sinabi nating mantle, it is the rocky inner layer above the core, no? Nga lang, in viscous liquid form lang siya, no? Or semi-molten rock, no? Now, the plates act like a hard and rigid shell compared to the Earth's mantle. Now, this strong outer layer is called lithosphere. So yun nga, etong mga plates na yan, these are still part of what we call lithosphere, no? Na kung saan napakalutong na mga bato, and then ito ay nagkikiskisan sa bawat isa. Yan. So kawawa, halimbawa, ayan, may mga malalaking plate dito. Yan, Pacific plate, and then we have North American plate, and then South American plate. So yung mga nasa pagitan niya ng mga maliliit na plate, definitely yan ay kumbaga sinisiksik, no, ginigit-git nitong mga malalaking plate, no. Kaya yan din sa mga pagitan na yan. So napakarami rin syempreng mga earthquake, di ba, na nangyayari. Yan. Now we have here Alfred Wegener.
Have you ever had the experience where you see a younger relative or friend after not seeing them for a few years, and you're taken aback at how much they have grown? We have an image in our minds as to what they looked like the last time we saw them, and they're much different. If the continents of the Earth move and grow, why don't we notice that? Well, for 2 reasons. 1, we really don't see what whole continents look like in real time. And 2, they move so slowly that people die before any noticeable changes can take place. As far back as 1620, people often noticed that the coastlines of North and South America looked like they fit together with Europe and Africa. These observers noticed these coastlines, but had no easy explanation for how that could have occurred, since everyone believed the continents were stationary. Solving this mystery would take the work of a geologic supersleuth. Alfred Wegener, a German meteorologist, was the first to begin to work out details to explain this interesting observation. To begin with, the current geologic theory was that the crust was all stationary and continents were relatively unchanging. They didn't move around. Alfred Wegener knew that other people had made observations of the fit of the coastlines. He accidentally became drawn into that topic by discovering evidence that might explain that phenomenon. In the fall of 1911, though, he came across a scientific paper that described the locations of identical plant and animal fossils on very different continents. These fossils included Mesosaurus, which was a freshwater reptile, Lystrosaurus, a land reptile, Cyagnathus, a land reptile, and Glossopteris, which was a tropical fern. These were on very different continents, and he wondered how could these same plants and animals be on such different land masses? How could they have migrated over such vast distances or survived in such harsh conditions? The current theories were that the continents were connected by land bridges that have since eroded away, or by stepping stone islands. Stepping stone islands would be a series of islands that traversed the ocean. Wegener developed a much simpler hypothesis that stated perhaps the continents were all together at one point, thereby also explaining the fit of the coastline. He then theorized a supercontinent he named Pangaea, which meant one Earth. He realized, though, that if this idea were to be accepted, he would need much more supporting data than he had, just fossils and fits of coastlines. Other clues came from more research. He discovered that in his Pangaea model, large geologic features such as mountain ranges on separate continents often lined up closely. Rock strata from Africa and South America also matched when placed together, South America and Africa lining up. Puzzling data of fossils of plants and animals found in climates where they could never have survived was also explained, similar to the Glossopteris tropical ferns growing in Antarctica. Coal was found in Antarctica and Britain, areas that could never support coal formation today. Putting all this data together, Wegener concluded that the continents were, at one time, all together in a giant supercontinent, and that somehow they broke apart and migrated to their present location. There was some trouble with this theory, though. He called his theory continental drift, and talked to many other scientists and geologists about it. His theory overall was soundly rejected, and often in harsh and scathing language. The big problem was that Wegener had no convincing evidence for how the continents might actually move from place to place. He thought the continents broke through the ocean floor, much like an icebreaker plows its way through an ice sheet. There was some scattered support for his theory, but he passed away before the discoveries that would provide the mechanism for his theory and ultimate acceptance. As countries began to map the ocean floor after World War II, additional surprising clues from the geography of the ocean floor were brought to the surface, which would ultimately provide a mechanism for his theory and lead to ultimate vindication. These included underwater mountain ranges and the separation of the ocean floor at giant cracks. Many people had observed clues about the Earth's past and could not put them together to solve the puzzle about how the Earth operated or how continents moved. Based on the fit of the coastlines, fossil evidence, rock types, and mountain ranges found on separate continents, Alfred Wegener developed a new theory he called continental drift. Unfortunately, he failed convincing the jury of public opinion that he was on the right track, but ultimately this geologic supersleuth would be proven correct by future discoveries from the ocean floor.
Okay, so again, that's continental drift theory. No? So going back, we have here pieces of evidence about this continental drift theory. Again, continental drift theory was proposed by Alfred Wegener, and sinasabi na at one point in time daw, etong ating mga continents, although magkakalayo sila ngayon, no, at this present time, magkakalayo sila, pero at one point in time, ayun nga daw, magkakadikit daw etong mga plates na ito. No? And doon nga pumasok yung tinatawag na continental drift theory. Ngayon, ilan sa mga pieces of evidence na meron tayo dito sa continental drift theory na to, or dito nga sa tinatawag na nating Pangaea, no? So, may ilan sa mga ancient life forms, no, na makikita, no, sa iba't ibang bahagi ng mundo o dito sa iba't ibang mga continents natin, 'di ba? So, imagine, no, may kita isang halimbawa same organism pero nakita yung fossil nito sa magkaibang continents na meron tayo. So, isa 'yon sa dahilan, no, or isa yun sa pwede natin gamitin as evidence na maaari nga talaga na magkadikit at one point in time, magkadikit itong mga plates natin. So let's say for example, we have here what we call Synognathus, no? Yan. So it is a land reptile, no? And ang fossil ng organism na to, Synognathus, ay nakita sa South America as well as sa Africa. So imagine gaano kalayo 'yun, no? So sinasabi rin na baka naman din daw, no, isa sa pwedeng assumption nila na baka daw merong mga sinaunang island na kung saan yun daw yung mga ginamit nitong mga organism na to para makatawid daw doon sa mga plates na to. Nga lang, ayun nga, no? So since ang dami kasing evidence, no, kaya kahit papano, ayun nga, napatunayan siya. Still, meron pa rin mga mas marami yung kanyang mga evidence, no? And then next we have here what we call Mesosaurus, no, which is a freshwater reptile, no? So ito ay nakita, ang fossil nito ay nakita sa South America at the same time sa Africa rin, no? And then we have also what we call Trosaurus. Yan. So land reptile siya na matatagpuan naman sa Africa, yan, sa India, and even Antarctica, no? So imagine, no? So tatlong lugar, no? Or kumbaga mga plates or continents, no? Although ang India ay hindi naman continent yan. Or syempre kasama siya sa Asia, pero still, 'di ba? Kung napapansin niyo, tatlong continents pwede siyang matagpuan, no? And then last ay yung Glossopterus, no? Glossopterus. So ito ay isang tropical fern, no? Tropical fern. Pag sinabi nating tropical, ibig sabihin ito yung mga lugar na kung saan may init, no? Directly tinatamaan ng araw. Ngayon, balik tayo dito sa Glossopterus. So ang Glossopterus ay ang fossil niya ay nakita sa South America, sa Africa, sa Asia, Antarctica, and Australia. And imagine, no? Imagine ang Antarctica as well as ang Australia ay mga malalamig na lugar. Pero bakit merong natagpuan na fossil ng Glossopterus doon, no? So isa nga 'yun sa dahilan, no, or evidence, no, na talagang at one point in time magkakadikit etong mga continents natin, no? Now, how the continents form, no? So talking about Pangea nga, no, wherein ito yung pinakamalaki, no? So yung tinatawag na supercontinent Pangea, no? So magkakadikit lahat ng mga plates natin na meron tayo at this point in time, at this present time, no? Ngayon, no, that is Permian era, no? And then that is around 235 if I'm not mistaken, no? Yan, million years ago. And then, no, anong nangyari dito sa supercontinent Pangea natin? So continents were constantly moving that resulted to splitting of supercontinent into two major continents. So nahati siya sa dalawa. We have what we call Gondwana land, no, and Laurasia. Again, Gondwana land and Laurasia. So the continent further moved, eventually leading to the 7 continents, no, that we have at present time, no. Yan. So from Pangea, nahati sa dalawa, Laurasia and Gondwana land, and then eventually unti-unti siyang yun nga, nahati, naghiwa-hiwalay, nag-move hanggang sa ayan, ngayon at this present time, ayan, meron na tayong 7 continents, no. Now, etong mga i-discuss ko, ayan, simula kanina naman, lahat naman itong mga dinidiscuss ko, lahat to ay nasa libro, no? So, kung meron man kayong question, ayan, pwede nyong, or hindi naintindihan gaano, pwede nyong tingnan doon sa libro, no? Ngayon, di-discuss ko lang, no? Yung mga eras, no? Or the history of the earth, no? With these eras, no? So, ano ba yung mga events, di ba? Mga nangyari, no, dito sa mga eras na ito, no? We have the first one, pre-Cambrian time, no? Pag nahanap ko yung mismong video, no, ng BBC about this history of the earth, i-share ko siya sa inyo, ipapanood ko siya sa inyo, no? Anyway, ayan, so we have pre-Cambrian time. Again, we are talking about the history of the earth, ha? So, our planet daw was spinning rapidly and it looked like an alien planet. So, during the early time, syempre, wala pa ngang buhay, di ba? Bago pa lang yung ating planeta. So, kumbaga, para siyang magma, no? Para siyang buong planeta natin, no? It is made up of, kumbaga, kumukulong bola, no? Now, ayun nga, we have here molten lava. So, yun nga, molten lava was flowing. And then, it took only 6 hours for a day to last. No? So, ibig sabihin, yung isang araw ay natatapos lang, no? Sa 6 na oras. So, ganun kabilis, ganun ka, kumbaga, unstable yung ating planeta during that time, no? And then, gravity made all things in order with the heavier elements forming the core. So, during the early times of the planet Earth, ayun nga, no? So, unti-unti pa lang siya nade-develop, no? So, yung core natin, nabubuo pa lang, yan. And then, lighter materials floating and turning into crust. So, ibig sabihin yung mga heavier elements, iron, yan. So, yung mga elements na yan, yung mga metallic elements na yan, usually sila ay napunta, no? Yan, napunta doon sa center ng ating planeta due to the presence of gravity. And then, dun sa mga light elements naman, no, light materials, sila naman ang napunta sa crust, no? Ayan, and with that nabuo yung ating crust, no? Now, the molten iron and nickel core created a magnetic field that protect the Earth from harmful charged particles in space and allowed life to span, no? So, ibig sabihin, dahil nga dun sa, ayan, napunta nga kasi, no, ang mga heavier elements doon sa center ng ating planeta, with that, nagkaroon din ng magnetic field ang ating planet Earth. And ito ay pinoprotektahan tayo with the harmful charged particles, no, na nanggagaling sa outer space and even sa sun, no? And then, aside from that, ano pang nangyari during this time, pre-Cambrian time? So, about 4.5 billion years ago, the planet hit by an object as huge as Mars. So, ibig sabihin, may isang astronomical object na kung saan bumangga, no, nag-collide, no, dito sa ating planeta, no? And then, molten debris created another sphere moving around the Earth known as Moon. Dahil dun sa collision na yun, no, kumbaga merong natira, no, natira doon sa bumangga sa atin na astronomical object. And then, eventually, no, naging debris siya, and then, naging moon, no, naging satellite ng ating planet Earth. Now, the impact tilted the Earth's axis of rotation, creating season and provide stability to the planet. Ibig sabihin, dahil dun sa collision na yun, so, kumbaga, ginulo niya yung ating planeta, no? So, ginulo niya. And then, ayun nga, naging tilted, no? Bahagyang, kumbaga, tumagilid yung ating planeta. At dahil doon, ito na may naging dahilan kung bakit nagkaroon tayo ng different season, no? And stability, no? Naging stable na rin yung ating planeta. So, the tilted axis of the Earth lengthens the day into 24 hours and cools down the Earth, no? So, ganun lang kasimple. Ayun nga, kumbaga, naging stable na yung ating planeta. So, nagkaroon na tayo from 6 hours, no? Yung isang araw natatapos lang sa 6 na oras. Ngayon, no, during this time, ayun na, naging 24 hours na ang ating isang buong araw, no? And then about 4.4 billion years ago naman, the Earth's surface was too hot, no? Sobrang init ng surface ng ating planeta, no? And then dahil sa sobrang init, ayun nga, no, naglabas ng napakarami kasing carbon dioxide yung mga volcano, no, na merong during these times, no. Napakarami kasing volcano during these times, no. And dahil nga naglalabas sila, no, nag-eject sila ng carbon dioxide, so sobrang init ng ating atmosphere ng ating planeta. At dahil sobrang init, ayun, ano nangyari? Nagkaroon ng pag-uulan, no. So, rain poured down from the sky for millions of years, no? So, imagine, nagkaroon ng pag-uulan sa loob ng ilang milyong taon. And dahil sa tagal ng panahon ng pag-uulan na to, it creates bodies of water, no? So, nagkaroon na ng dagat, no? At iba pa bodies of water. Now, in these bodies of water, abiogenesis took place. Pag sinabi nating abiogenesis, it is the origin of life from non-living matter. So, ibig sabihin, from non-living things, nagkaroon na ng mga organism, no? That is abiogenesis. Now, key element combined together forming the foundation of all life forms, o yung tinatawag nga na DNA, no? Yan. So, nanggaling tayo, syempre, nanggaling itong mga early life forms na to sa mga bagay na walang buhay, no? Sa mga chemicals lamang, no? Now, these molecules created the first organism, yung tinatawag na bacteria. Ibig sabihin, ang life ay nag-originate sa bacteria. At ang tawag nga doon ay cyanobacteria, no? And itong cyanobacteria na to, no, in order para masustain niya yung kanyang buhay, nag-undergo siya ng process ng photosynthesis. Ibig sabihin, ginamit niya yung sunlight, yung water, at yung carbon dioxide na meron sa atmosphere during that time in order para masustain niya ang kanyang buhay, no? Now, these oxygen molecules occupy the primeval ocean and reacts with iron. Ayun nga, dahil nga 'di ba, nagkaroon nga no ng mga cyanobacteria na nag-undergo ng process ng photosynthesis, ang naging product nitong photosynthesis na to, nitong cyanobacteria na to ay oxygen. At dahil sa dami ng cyanobacteria during that time at sa tagal din ng panahon, dumami rin ang oxygen content ng ating atmosphere, no? And then later, they escape into the atmosphere, creating the ozone layer that further protected us from the harmful radiation of the sun. Ayun nga, no? So, dahil nga may inabuo ng oxygen, may mga carbon dioxide, as well as yung iba pang mga gases, ayun na, nabuo na yung ating ozone layer, na kung saan itong ozone layer din na to ay pinoprotektahan din ng ating planeta, ang mga organism dito sa ating planeta. Now, large solid continents appeared, making the crust more suitable, and then this leads to Cambrian explosion, no? So, mamaya i-discuss ko yan. So, that is pre-Cambrian time, no? Next era is Paleozoic era, no? So, about 550 million years ago, with oxygen in the primeval ocean and the atmosphere, marine constitutes or communities, marine communities, yan, flourish, no? So, ibig sabihin nga, nagkaroon na ng, ayun, gumanda na, no? Umayos na yung oxygen content, yung percentage ng oxygen dito sa ating planet Earth. And dahil doon, no, yung iba pang mga, ayun nga, nagkaroon na ng, ayan, mga early fishes and aquatic plants develop. So, may mga nabuhay na, no, na mga isda, no, as well as mga aquatic plants, no, sa tubig, no. And then later, plants began to occupy the land, and soon some forms of fishes also conquered the land. Ibig sabihin ay nga, no, so yung mga halaman na nabuhay nga doon sa tubig ay nabuhay na rin doon din sa lupa. At yung mga isda na nabubuhay lamang sa dagat ay trinay nila, no, na makapaglakad sa lupa, no, hanggang sa ay nga mag-evolve sila, mag-adapt sila, no, hanggang sa magkaroon na sila ng paa, no. Now, the first amphibians emerged from the ocean and live on land. So, pag sinabi nating amphibians, no, ibig sabihin during this time, may nabuo na daw na amphibians. Pag sinabi nating amphibians, these are small vertebrates that need water or a moist environment in order to survive. No? Halimbawa, yung mga frogs, 'di ba? Yung mga toads, 'di ba? Yan. So, yung mga organism na to, so those are amphibians. So, mabubuhay sila doon sa mga lugar na medyo or basa, no? So, all can breathe and absorb water through their very thin skin. Itong mga amphibians na to, itong mga organism na to. Yan. Next. However, yan, sabi dito, amphibians could only reside near water for them to deposit their eggs. So, definitely, ayun nga, no, para nga, again, masustain nila ang kanilang buhay, kailangan nilang tumira doon sa mga lugar na malapit sa tubig. At bukod doon, syempre, since malapit sila sa tubig, kapag sila ay nangingitlog, doon nila nililay itong mga eggs na to, no? Doon nila dinedeposit, no? Now, later, they develop the ability of producing hard shells, no? So, yung mga unang itlog nila, no, nitong mga amphibians na to, syempre yung mga shell na to ay hindi ganun katitigas, no, hindi ganun kagaganda. Kaya sa tubig sila nangingitlog. Nga lang sa pagdaan ng panahon, ay nga nag-evolve, nag-adapt, so nagkaroon na ng hard shell etong mga itlog nila. Ngayon, since meron ng hard shell, so this allow them to carry their eggs anywhere on land, no. So pwede na nilang ma-lay yung eggs nila kahit saan sa lupa, hindi lamang sa tubig kundi pati na rin sa lupa, no. So reptiles and insects also emerge So may mga nabuhay na ng mga reptiles as well as insects during this Paleozoic era, no? And then about 250 million years ago, volcanic activity filled up the atmosphere with carbon dioxide. So yun na naman, no, may mga umusbong na naman, no, may mga lumabas na naman sa lupa, no, na mga or mga nag-erupt na mga volcano sa lupa, no? At dahil sa pag-erupt na yun, ayun nga, so nagkaroon na naman, naglabas na naman ng carbon dioxide etong mga volcanoes na ito. And then species that evolved during the Cambrian time got extinct, leading to Permian extinction. So yun nga, nag-extinct, no? Dahil sa sobrang init kasi, no? Sa sobrang init, dahil dito sa mga volcano na biglang nagsilabasan sa lupa, nag-erupt, no? Naglabas ng maraming carbon dioxide, no? At dahil doon, ayun nga, no, na matay tuloy yung mga organism during that time, no? Now, this marked the end of Paleozoic era and the new era emerged, giving birth to new dominant species, no? So dito na pumasok ang Mesozoic era. So it is the age of the dinosaurs, no? Yan, Jurassic, diba? Yan. So dito na sa Mesozoic era 'yon, no? Anyway, nasa libro to, guys, ha. Paki-check nyo na lang, no? Nasa libro to. Now, this was the time when gymnosperm emerged and the land was dominated by reptiles, no? Pag sinabi nating gymnosperm, etong era na to, during this era, ay nga, may mga nabuhay na, no, na mga tinatawag nating gymnosperm. Ibig sabihin ng mga gymnosperm, it is a group of vascular plants that produce naked seed. So ibig sabihin ito yung mga halaman na nagpo-produce ng seed. And nabanggit ko yung vascular, ibig sabihin ito yung mga halaman na merong tissue, yan, merong roots, merong stems, and merong leaves, no? Yan yung mga vascular plants o yung mga gymnosperm. Now, mammals started to evolve too, but were held back by the dinosaurs. So yun nga, although yung mga mammals, di ba, ay nag-evolve, no? Nga lang kasi during that time kasi, di ba, ito mga, usually kasi ito mga dinosaurs na to, ito ay mga carnivores. So ibig sabihin, kakainin niya rin kung sino yung mga kung ano yung mga nasa paligid niya ng mga dinosaurs, no? Now this supercontinental Pangaea began to separate, forming the Rocky Mountains. So during this time then, ayun na, no, unti-unti, no, nagkakaroon ng hihiwalay ng mga plates natin o ng ating Pangaea. So the dominance of the dinosaur during this time then face an end, no? Sa paanong paraan? During that time kasi, so nagkaroon ng asteroids, no? So yung asteroids na bumagsak, no, dito sa ating planeta. At dahil dito sa mga asteroid na to, ito yung dahilan kung bakit nagkamatayan, no? Nag-extinct etong ating mga dinosaurs, no? Dahil sa mga asteroids na yan. And then last era natin is Cenozoic era. So about 65 million years ago, the continued evolution of mammals, birds, insects, and flowering plants took place, no? So during this era, ibig sabihin lahat ng mga organism natin ay talagang dumami na, nag-evolve, no? Now mammals became the dominant species and the first primate evolved. Ibig sabihin during this era rin, ayan, Cenozoic era, may mga primates na nabuhay. Ibig sabihin ng primates, mga sinaunang mga tao, no? Kumbaga mga unggoy pa, no? Now, aside from that, major crustal movement occurred during this era rin, no? Creating mountains like Himalayas, connecting North and South America. So, yun nga, nabuo na, no? Dahil sa movement ng ating crust, no? So, anong nangyari? Nabuo yung ating mga kabundukan, di ba? Kapatagan, di ba? Mga volcano, no? Now, as these two continents connected, it disrupted the ocean current in the Atlantic, altering the climate and deforming the ice age, no? Dahil dito, sa disruption na nangyari, no? Now, as the Earth cooled down, our primates ancestor inhabited warm climate of the tropics, no? So ibig sabihin ay nga, no, dahil nagkaroon ng taglamig, no, sobrang lamig. So yung mga primates natin, syempre natutunan na nila, no, na mag-adapt sa environment, no? Now, about 10 million years ago, new plant species o yung tinatawag nga ng mga grasses na yan. So yung grasses emerged and dominated the land, giving way to grassland. So yun nga, during this era rin, ayun nga, nagkaroon na rin ng grassland, no? Na syempre nagsusustain ng life ng iba pang mga organism. And then early primates inhabited most of the treetops, but as the grassland emerged, they moved to explore it. So usually itong mga primates na to nakatira sila sa mga puno, no? Gumagawa sila ng bahay doon. Nga lang, dahil nga nagkaroon ng grassland, no? And then, dito nila natagpuan yung iba nilang mga pangangailangan. Siyempre, pag pangangaso, for example, dyan sa grassland, ayun, no? Yan. Nag-evolve sila, no? Nag-explore sila. Next, with fewer trees, the apes adapted and moved into grassland, no? And then with tall grasses, they started walking on 2 feet and free hands. So yun nga, no, kumbaga nga parang mga unggoy, no, naglalakad, nakayuko, baluktot yung binte tsaka paa, hindi nakakatayo ng maayos, no. So during that time na nagkaroon na nga kasi ng mga grasses, unti-unti na, no, pinilit nitong mga primates na to na makatayo, no, makapaglakad ng maayos, no. And then yan, they later evolved to become the first humans. So yung tinatawag nating hominid, etong mga primates na to, no. So tagal ba naman ng panahon, syempre ay nga, no, nag-evolve na sila, nag-adapt na sila sa environment, kaya nabuo na yung tinatawag na hominid, no. Now, from that day on until the present time, humans dominated the planet. So, alam naman natin yun, di ba, na tayo ngayon ang kumokontrol, no? Ang pinakamaraming bilang na organism dito sa ating planeta, no? Now, the whole history of the Earth has been identified and studied through radiometric dating and fossil analysis, no? So, yan. Kaya, nagkakaroon tayo ng iba't iba pang mga information with regards to these eras as well as yung mga organisms, no, or history ng ating planet Earth, no. Now, according to geologists, the movement of plates can be attributed to 3 possible forces, no. Bakit nga ba gumagalaw yung plates ng ating planet Earth? Dahil yan sa mga sumusunod. Una ay yung gravity. So, the denser materials are pulled by gravity and making them sink gradually, move across each plate. Yun nga, dahil sa gravity, yan, so ano nangyayari dun sa ating planeta or sa ating mga plates. So definitely, ayan, ito yung naging dahilan kung bakit gumagalaw itong ating mga plates, no. And then convection current, so the material within the asthenosphere, no, circulate due to the differences in temperature. So, ayun nga, no, balik lang tayo ulit sa gravity. So, gravity is the most common force that shapes the Earth's surface, no? Kung bakit tayo may iba't ibang surface o geological landscape, dahil yan sa, yan, most of it ay dahil sa gravity. Now, talking about convection current naman, kaya nga nagmumove ang ating plates kasi nga, merong paggalaw dun sa ating plate, no, or dun sa ating mantle. Merong gumugulong, merong something na nagpupush, no, in order para mag-move or magkaroon ng mag-process itong ating mantle, itong ating convection current, no. And then number 3 is mantle plume or thermal plume. So mantle plume are vertical columns of the molten materials that rise up from the mantle. So ito nga yun, no, ito yung ating tinatawag na mantle plume. So ito yung ating crust, and then hinahayaan lang natin, di ba? Hinahayaan lang natin na dito, no, dumaan yung ating mga energy na nanggagaling diyan sa core, no? Diyan sa mantle plume dadaan, and then syempre ito yung maging dahilan kung bakit nagmo-move din itong ating mga plates sa surface ng Earth, no? Next is sea floor spreading. So dahil nga sa different geological process na nangyari sa ating planet Earth, syempre yung ating sea floor din ay nagmo-move, no? Nagmo-move yan. So sea floor spreading is a new process that occurs of or at mid-ocean regions where oceanic crust is formed through volcanic activity dahil sa paggalaw ng lupa, dahil sa paggalaw ng volcano. Ano nangyari dito sa ating crust, no? So yun nga, nabubuo, no? Okay, so ayun, since ang sea floor is part pa rin ng crust, no? Ayan, syempre kapag nagkakaroon ng paggalaw, nagkakaroon ng volcanic activity, definitely yung mga plates din doon sa ating sea floor ay naghihiwalay din, nasi-stress din sila, no? Yan, katulad na lang for example nito, no? Ayan. So, ito ay example ng sea floor, no? Nga lang, ayan, nagkakaroon ng paglayo, no? Ng paggalaw dahil nga sa different processes na nangyayari din syempre sa ating planeta. And then we have also what we call isostasy. Pag sinabi nating isostasy, it is the state of gravitational equilibrium between the Earth's lithosphere and the asthenosphere such that the tectonic plates float at an elevation which depends on their thickness and density. Ayun nga, no, guys. Ang idea lang naman, no, para mabilis tayo, ang idea lang naman ng isostasy is that merong gravitational equilibrium, no, sa isang lugar, no? At dahil sa gravitational equilibrium na yon, once na magkaroon ng mountain formation, hindi siya ganoon kataas, no? Kasi balance yung tinatawag nating ay gravity, no? Yan yung isostasy. Ngayon, kung halimbawa naman, no, halimbawa sa Himalayas, no? Kung aware kayo doon, Himalayas, kung saan matatagpuan ang Mount Everest, no? Dito sa area na to, wala silang state of gravitational equilibrium, no? Gravitational equilibrium. Kaya sobrang tataas ng mga mountains na nabubuo doon sa Himalayas, no? Now, aside from that, it explains how different topographic heights can exist at the Earth's surface, no? So yan. Now, last is plate boundary. So, our Earth's outer layer, yung crust nga, is divided into set of large moving plates. So, the lines where they meet are called as plate boundaries. So, tinatawag yun as plate boundaries, no? So, the line or the lines where they meet are called plate boundaries. So, there are three main types of plate boundaries. We have divergent, convergent, and transform. So, pag sinabi nating transform, it occurs when two plates slide or grind each other. So, nagkikiskisan lang sila, papalayo sa bawat isa. So, ang best example nga niyan ay yung San Andreas Fault. Kaya nagkakaroon ng folding yan dahil nga doon sa fault, no? Dahil nga doon sa tinatawag na transformation boundary, no? And then, we have also what we call divergent boundary, wherein, pag sinabi naman divergent, ayan, humihiwalay sa bawat isa, no? Yung ating mga plates, no? And then, last is the convergent boundary. So, sa convergent boundary naman, kung ang divergent boundary ay naghihiwalay, sa convergent boundary naman, it occurs when two plates move towards each other. Nagmo-move naman papunta sa bawat isa, no? Nagbabanggaan na, nagkikiskisan. Itong ating convergent boundary, no? Now, we have here this convection current. Paano nga ba nangyayari itong ating convection current?
And then you're going to get right.
All right, so we know that the driving force behind plate tectonics now is convection currents. And if we apply those convection currents in the mantle, which is a fluid-like material, we'll see how they can start to drive the plates which sit above it right here, moving the plates all around. Well, what we want to look at is what happens now at these boundaries because of these convection currents. This figure shows three different types of boundaries.
So that is actually the end of our lesson for today. Now, if you have any question, feel free to ask. Pwede nyo akong i-chat sa Facebook. Pwede kayong mag-chat sa GC. No? Okay ba yun, guys? Okay. So, yun na nga, no? Ayan. So, that is our lesson for today. I hope you have learned something new today, no? So, mag-iingat kayo and God bless everyone. Bye!